Over the years, I've seen a lot of positive changes in our industry, changes that help us do things more efficiently and more effectively. Sometimes change can be a little hard to get used to, but when the changes are good ones, it's well worth the effort.
Recently, OSHA revised its hazard communication standard. The agency decided to make the standard work as part of a globally harmonized system for communicating chemical hazards. For mechanical construction and service workers, this means that every chemical label and every safety data sheet will be identical in its format. We work every day with chemicals that can burn, emit toxic fumes, react violently with other chemicals, and create many other types of hazards. Chemicals can get into your body in several ways, such as through inhalation, absorption through the skin, and ingestion or swallowing.
Sometimes chemicals can even be injected into your body. Fortunately, we have some rights that help us protect ourselves from chemical hazards. OSHA's Hazard Communication Standard gives us the right to know about the chemical substances we could be exposed to in the workplace and how to protect ourselves from those hazards.
The standard requires each company to develop and implement a hazard communication program.
If you know how and where to get the necessary information, it's pretty easy to protect yourself and everyone around you from chemical hazards.
So, where do you find this information? A good start is right on the container label. Every container on the job site should be properly labeled. The labels should be in English, easy to read, and prominently displayed on the containers. Each label will have a product identifier, a signal word, one or more pictograms, a hazard statement, a precautionary statement, and contact information. The product identifier is nothing more than the name or number used for a hazardous chemical on a label or in a safety data sheet. It's there so the user can quickly identify the chemical substance. A signal word is one word used to alert you to the severity of the hazard. The two signal words are danger or warning. Danger is used for more severe hazards. A pictogram is a symbol that gives you specific information about the hazards of a chemical. There are a total of 8 pictograms required for worker safety on labels and safety data sheets. There's a 9th pictogram for the environment, but it doesn't apply to workplace safety. Let's take a look at the 8 different pictograms that apply to us. The first pictogram is for health hazards. Prolonged exposure to chemicals covered by this pictogram may cause health problems such as cancer and birth defects. An example is gasoline. The benzene ingredient is a known carcinogen. Keep in mind, a single chemical or chemical mixture may have more than one type of hazard and therefore more than one pictogram. This pictogram also covers mutagenicity, reproductive toxicity, respiratory sensitizers, target organ toxicity, and aspiration toxicity. The next pictogram is for flame hazards. The flammable chemicals covered by this pictogram can burst into flames fairly easily. Acetylene would be an obvious example in our line of work. Chemicals that fall under the flame pictogram include flammables, pyrophorics, and substances that could also be self-heating, emit flammable gas, are self-reactive, or contain organic peroxide. The exclamation mark pictogram covers chemicals that can cause immediate health effects, such as skin rashes or respiratory irritation. One example is soldering flux, which can cause eye irritation, allergic skin reactions, and respiratory irritation. The gas cylinder pictogram warns you about gases that are under pressure, which can explode or propel the cylinder if it's heated, ruptured, or leaking. One common example is a propane cylinder. The corrosion pictogram covers chemicals that can seriously damage skin and eyes. One example would be sulfuric acid, battery acid. The exploding bomb pictogram addresses chemicals that can blow up, like explosives, self-reactives, and organic peroxides. The pictogram flame over circle warns you about oxidizers, chemicals that cause other materials to catch fire or explode. One example is oxygen. The final pictogram in the new system is the skull and crossbones. This identifies chemicals with acute toxicity, which could be fatal or toxic, like condenser coil cleaner. Those are the 8 pictograms that visually help you figure out the hazard category. The hazard statement describes the nature of the potential hazards. Let's look at the hazard statement for acetylene. Contains gas under pressure, may explode if heated. Extremely flammable gas. The precautionary statement describes the recommended protective measures you need to take.
Think of it as the precautions you need to implement to protect yourself and those who are working around you.
The precautionary statement tells you how to prevent exposure to a chemical and how to store and handle a chemical safely. Here's the precautionary statement for oxygen. Keep away from combustible materials. Keep valves and fittings free from oil and grease. In case of fire, stop leak if safe to do so. Store in a well-ventilated place. The contact information on the label lists the chemical manufacturer, importer, or other responsible party's name, address, and telephone number in case you need to contact them for any reason related to that chemical.
If you need more information or you have a question that isn't answered on the chemical label, the next step is to go to your company's hazard communication program.
Go to the chemical information list. This is an inventory of all the chemicals used on the job site. The list has a number, letter, or other symbol that directs you to the right SDS. What we now call an SDS, or Safety Data Sheet, used to be known as a Material Safety Data Sheet, or MSDS. An SDS still serves the same purpose, to provide more detailed information about a chemical substance than what you'll find on the label.
In the past, each manufacturer or supplier could format the MSDS differently. Now it's going to be much easier for you. All of the new SDSs will be formatted the same way, so the information you're looking for will always be in the same place.
As you'd expect, the SDSs are pretty detailed, but you don't need to be a chemical expert to use them effectively. What you really need to be able to find fairly quickly is what chemical you're working with, the hazards that are associated with it, and how to protect yourself from those hazards.
The new SDS is divided into 16 sections, but you won't need to reference all of them.
Section 1, Identification. This is where you find the product identifier, recommended use, contact information, and an emergency phone number. Section 2, Hazard Identification. This section requires a more detailed explanation. In it, you'll find that the chemical is classified according to the nature of the physical hazards, such as a flammable solid, or health hazards, such as a respiratory sensitizer. Where it's appropriate, this section will also show a hazard category or subcategory by a number, or a number and a letter. The bottom line, the lower the number, the higher the hazard. Let's look at some examples. There are 4 categories for flammable liquid hazards. Category 1 chemicals are more flammable than Category 2 chemicals. The least flammable is Category 4. For skin corrosion and irritation hazards, there are only 2 categories, 1 and 2. A 1 hazard is worse than a 2 hazard. Within these 2 categories are subcategories A, B, and C. A hazard that is 1A is worse than a 1B hazard, and a 1C hazard is worse than a Category 2 hazard. You get the idea. This is different than what you might remember from the NFPA 704 diamond, which is still being used to communicate chemical hazards. In the 704 diamond, the higher the number, the more severe the hazard. Be aware that you might find both systems of communication on an SDS.
All of this may be a little confusing at first, but if you focus in on the hazard statements and pictograms, you'll be able to effectively identify the hazard. If you have any questions about hazard identification, talk to your supervisor.
Next is Section 3, Composition and Information on Ingredients. This is where you can learn the chemical composition. The only exception is if the composition is a trade secret, then it won't be listed in detail. Section 4, First Aid Measures. Here's where you find out what to do if anyone has an injury or illness due to a chemical. Section 5, Firefighting Measures, tells you the proper type of extinguisher and protective equipment to be used in the event of a fire. Section 6, Accidental Release Measures. This section describes the precautions, protective measures, and emergency procedures in case of accidental release. Section 7, Handling and Storage, outlines safe handling techniques and conditions for safe storage, including incompatibilities. Section 8, Exposure Controls, Personal Protection. This is where you can learn about exposure limits, engineering controls, and protective measures, including what personal protective equipment you'll need. Section 9, Physical and Chemical Properties, is a list of all the many different characteristics that can impact safety. Section 10, Stability and Reactivity, show you possible hazardous reactions. Section 11, Toxicological Information, describes various health effects and possible acute, short-term, and chronic, long-term effects of exposure. Sections 12 through 15 do not apply to workplace safety. Finally, Section 16, Other Information, shows you how current the SDS is and when it was last updated.
Remember, every SDS will follow this format. No more shuffling around to find information about personal protective equipment. Now you know to go right to Section 8 to find out what you need.
We've talked about all the parts of the system designed to keep you informed about potential hazards. Now let's walk through a couple of examples to see the globally harmonized system in action. Let's say you have to use some PVC primer and want to know more about the hazards. Start by looking at the label. The signal word is danger. You'll see two pictograms that indicate there are flame and exclamation mark type hazards. The hazard statement tells you that it's a highly flammable liquid and vapor. It can cause eye irritation, be harmful if inhaled, cause respiratory irritation, and result in drowsiness or dizziness. The precautionary statement tells you how to protect yourself, such as keep the primer away from ignition sources and avoid breathing dust, fumes, gas, mist, vapor, and spray.
But what if you're someone who suffers from asthma? You might be concerned about the respiratory irritation that was mentioned in the hazard statement. You need more information before you start using the primer. For this, you need to know where to access the Hazard Communication Program.
Go there and find the Chemical Information List. The Chemical Information List will show you where to find the appropriate SDS in the file. Go to that SDS and skim through the sections. Section 8 in the globally harmonized system always covers exposure control and personal protection. You'll see it states that you should use local exhaust as needed and always use the PVC primer in a well-ventilated room. So now you know what type of ventilation is needed in the area where you're working.
Let's try a different substance. Let's say you're using argon to purge a piping system and want to know more about the hazards. Let's start with the label.
We have our hazard category pictogram, gas cylinder, and the signal word, warning. The hazard statement shows that it contains gas under pressure and may explode if heated. It may also be an asphyxiant if inhaled in high concentrations. The precautionary statement directs you to store it in a well-ventilated place. That's helpful, but you want more information. There may be other chemicals in the area, and the air temperature changes can be extreme in the local climate. You want to know whether argon is reactive. Go to your company's written hazard communication program. Find the chemical information list. Identify the correct safety data sheet. Skim through the sections until you find Section 10, which is always about stability and reactivity. You can see here that argon is stable under normal conditions. Now you know that it's not normally reactive.
That's how the globally harmonized hazard communication system works. It makes it very clear what the hazards are and how to find the information you need to protect yourself and the people around you. Here are a few more requirements for working safely with chemicals.
After using a chemical, always wash your hands thoroughly before you eat, drink, smoke, or apply lip balm or makeup. That way you won't inadvertently swallow any of the substances. If you transfer a chemical from one container to another, try to take only the amount that you'll use right away. If you're unable to use it all and have to put it aside for use later, make sure the container is properly labeled according to the new globally harmonized labeling system.
You have the right to access your company's written hazard communication program and safety data sheets whenever you need to.
It's critical that you know where you can access them quickly on each and every job site. You should know exactly where this information is, what trailer, what computer, what file cabinet, what binder, wherever. If you have questions about any chemical substance or any part of the hazard communication program, ask your supervisor for help immediately.
It might be a while before all the chemical manufacturers, suppliers, and importers have their new labeling systems and SDSs in order, but many of them have already made the change. We'll be using both the old system and the new system for a while, but that's okay. Ultimately, changing to the globally harmonized system will improve the consistency and accuracy of classifying and labeling hazardous substances and make it easier to read the warnings. This will ensure that everyone understands the hazards they're working with and can effectively protect themselves.